So this is the Leica Sputter coater. It's used to coat samples that are non-conductive for the scanning electron microscope, or the SEM. As you notice, it's quite noisy. The pump should be on for this tool. So when you first come in, if you hit vent, it will turn the pump on and actually vent the chamber. In order to introduce a sample into the Leica Sputter coater, we generally put them on these stubs. And to put a sample on that, you could use the silver glue or the double-sided conductive tape. This is carbon-based tape. They do make a copper one as well, but if you remove the backing, then you can just stick the tape over top of the stub and peel him off to give this. And today I've just got a little piece of a silicon wafer, but so if this is our sample, we would place this on top. And now we have a sample that is conductive and is stuck to the stub. The tool has several functionalities. The main one is sputtering through a gold target. So you can switch out the stage. So the stage that's in currently actually rotates. And the other stage is just a flat one. So that can be loosened just by the turn of a screw, and you can lift the other one off and place this one on if you wanted a non-rotating stage. This stage I typically use if I want to use the carbon thread. So there's a gold palladium target in here now, but you could switch that out to use this carbon thread. People would use this for like EDX because carbon wouldn't show up in the analysis. So you could switch this out just by loosening these two screws here, and I'll actually do it. So if you wanted to remove the target, you could loosen these two screws, clamp this and remove it. And you can actually remove this gold palladium target by rocking it back and forth, and it comes out. And that's what it looks like. That's a relatively new looking target. So if I was going to switch, I would get IPA on a Q-tip and clean around the insides of that, just so I wouldn't have any gold palladium on that. But we're going to stick with this today. So this is what we're going to do. So we'll load him back in. We will screw it down. And this goes with the gold palladium. The other two goes with the carbon thread. So we'll make sure this is secure. This is clamped in. So this is our gold palladium target. That's the only one we typically have. We close that. Now we look at the inside. Like I said, you could switch this out, but we'll stick with the one that rotates. So on the home screen here, you have three options, right? You have glow discharge, sputtering, and carbon thread. We're actually going to do sputtering. So this is a video that's intended for sample prep for the SEM. So we have two samples. We could load those in. The one I showed previously was the piece of silicon wafer. You can put the stub, which has a male end, into the female recess of the stage. And then the other one would be the fruit flies that are secured on the stub. So now that we have both of those loaded, we can close the door and we can start to pump. But we want to turn on the argon. There are two tanks. One is oxygen and one is argon. The argon is actually hooked up to our Leica, so we will turn on at the tank. If you look on the tank, it says open and it tells you what direction. We won't mess with the regulator. It says no touch because that's already set. And then we'll turn it on at the bottom here as well. So argon is typically used because it's unreactive. So now that we've got that flowing over to the machine, let's go back and see how it works. When you arrive, the screen will probably show this because sputtering is the most popular, but if you hit the home key, it'll take you to the main screen. So this is where you can choose whichever experiment you desire. So sputtering is what we will do, so we will hit that and it'll bring us back to this screen. If you look, you've got several options that you can set up. So here is how far the stage is up. So if you've raised the stage higher, then you would hit plus and raise it up. If you decreased it lower than its home level, then you would do minus. So we just leave it at the standard height. This right here, it says quartz beside it. It's the quartz crystal microbalance, and that tells you how thick the film is. So we desire it to be 3 nanometers thick or 5, whatever you desire. If you go up to the top right of the screen, you can test and make sure the QCM is functioning. So if it shows you a frequency, typically that's a good sign. So we'll get out of that. And then the directionality. Do you want it diffuse or do you want it directional? And that's the path the gold and palladium atoms will take below. So we'll do diffuse is by far the most popular. So once you set all that up, you can go to the rotation if you've got that correct stage loaded, and you can test and see about how fast it rotates. So I think I've seen 3 to 5 is the most common. Typically 5 is what I do. So now that we've defined that we want 5 nanometers of metal deposited onto our substrates. We've got the stage in the right position. We've checked the QCM, and we've defined the rotation. We can just hit start now, and it will pump down, and once it achieves pressure, it will pump and purge a few times, and then at that point the sputtering event will occur. So let's just go ahead and hit start. You can hear the pump come on. It gets loud. So what's going to happen now is that it's going to pump this chamber to achieve vacuum, and then the sputtering event can occur. So here in a second, we're pumping down. You'll see the shutter at the top go over to the right and make a clear path for the target. So you can see the layer thickness is 3.8, 3.9, and the time is on the further right side, which shows 66 seconds now. And we define that as 5, so when it gets to 5, it should cut off. Which it did. So you hear the pump turn off, and the process screen tells you 5.1 nanometers was deposited, and it's venting, so we can click OK. And now it's going to vent the chamber, and we can then open the door and remove our samples. At the end of the experiment, when the chamber is vented, you can then open the door, and you can remove your samples. If they're in the back, I will actually turn on the rotation for a brief period to get them to move to the front. And you can use one side to hold the tool down, and the other side to pull the actual sample out. So that way we don't have to touch it and put fingerprints on the instrument. Then we need to store it at pump. So the instrument likes to be stored under vacuum, so make sure you hit pump and pump them over. At the end, the very last thing to do is to make sure you turn the argon back off. So we can turn it off here, and then actually turn it off on the tank as well. If you remember, if you forget which way it tells you close, is this way. So for me, that would be clockwise. And that's it for the Leica Sputter Coater.